everyone, this is Anjali Shrivastava from Institute of Engineering and Technology, faculty developer for this experiment along with my student contributors Shivam Kumar, Devika Rana, Radhika Bhatia and Asutosh Singh. So the aim of this experiment is to determine the moisture content of food by oven drying methods. For your better understanding, on this virtual platform, we have several sections for this experiment, that is aim, theory, pre-test, procedure, simulation, post-test, reference and feedback. So we will be moving one by one to each step. So next is moving to the next step, that is theory. Here we have mentioned the concepts related to the determination of moisture content, which you need to know before performing the experiment. Every food is composed of moisture and solid content. This moisture is responsible for the various functional properties of the food, and it is necessary to determine the moisture content of the food to decide the appropriate processing conditions and storage and transportation conditions for the food product. Also, on the basis of moisture content, the food is categorized in three parts, that is highly perishable, semi-perishable and non-perishable food contents. The methods, there are many methods to determine the moisture contents. Here we have taken oven drying method. Also, we can take this microwave oven drying method. We can take vacuum oven drying method to determine the moisture content. Okay, so the next section is about pre-test. So here you can see few questions which you can attend on the basis of your prior knowledge about the moisture content and the theory you have just gone through. So to attempt these questions, you have to just click on the circle against the correct option you think is, and after attempting all these questions, you can submit the quiz. The next part is procedure. In this procedure, we have mentioned all the materials required and the method which we have to follow to perform this experiment. Also, we have mentioned the formula we'll be using to calculate the moisture content. So before moving to the final simulation, you are suggested to go through these steps thoroughly. The next one is simulation, which I will come later. In the post-test test section, similarly like pre-test, you will be able to see some questions and you can answer it after performing the experiment. And at the last, after attempting all the questions, you can submit the quiz and get your marks, and on that basis you can decide whether you have learned from the experiment or not. In the reference, we have mentioned the reference books related to the experiments, and also you can get some theoretical knowledge about moisture and total solid analysis in the other book, that is Bradley RL, written by Bradley RL. AOAC International Official Method of Analysis will be including the standard method for moisture content determination. In the feedback section, you can give your feedback related to your experience after performing this experiment. So coming to the major part, that is simulation, here you can perform the experiment virtually. So firstly, you are suggested to make this full screen so that you can easily see what you are performing, and the steps which you are going to complete will be coming in this section, which is mentioned with the title task completed. So on your screen for first step, you can see here it is written press on button of the analytical balance. So basically this is analytical balance which we'll be using several times to take the weight of samples and other materials which are required for performing this experiment. So firstly, we are going to click on button, and moving to the next step. Here we have to take the weight of the Petri dish. So we are putting it on the analytical balance. So here comes the weight of the Petri dish, that is 30 grams. Moving to the next step, Here, in the next step, it is mentioned, press tear button of the analytical balance to make it 0. So you can already see that here the weight of the Petri dish is being indicated. So we will click on the tear button to make this reading 0. In the next step, we are going to place our sample for which we are going to determine the moisture content. So one question is being popped up here, that how much sample is taken to calculate the moisture content in oven drying method. So in this step, you can see it is mentioned weigh 5 gram of ground food sample. So you can easily say that 5 gram of the sample is required to determine the moisture content. Okay. So in the options, you can see that for the correct option, here it is mentioned that 2 to 5 gram of sample. So you can select the correct answer to move to the next step. Here on your screen, you can see the convective hot air oven, which is the instrument required to determine the moisture content. So in the step, it is mentioned that press on button of the convective hot air oven. So we are just clicking on the on button. Here you can see that written ST and PT. ST is the set temperature which you are going to set, and PT will represent the present temperature inside the convective hot air oven in degrees Celsius. So in the step, it is mentioned that set temperature to 105 degrees Celsius, which is the required temperature to determine the moisture content. So I'm going to make the set temperature value up to 105 degrees Celsius. And you can see while I'm making the set temperature to 105 degrees Celsius, the present temperature is also increasing, but at a slower rate. So let's make it 105. Let's set the temperature of convective hot air oven to 105 degrees Celsius. And after that, we can place our sample inside the oven for the moisture content determination. So now the set temperature is 105 and the present temperature of the convective hot air oven chamber is gradually reaching to 105. So let's wait for a few seconds. And after that, we can keep, once the present temperature is 105, we can keep the sample inside the convective hot air oven. So here one question appeared that is asking, what is the required temperature in degrees Celsius range for moisture content estimation in oven method? So you can see that we have set the temperature to 105 degrees Celsius. It means that 105 is the required temperature. So you can click here. Yes, we have the correct answer. So moving to the next step, in which we are going to keep our sample inside the convective hot air oven. We have closed the door. In the next step, it is written that after 2 hours, we have to remove the Petri dish from the oven. So after 2 hours, we are removing the Petri dish from the oven. We have taken 2 hours because the initial moisture removal rate is high. Now we are putting this Petri dish along with the sample inside the desiccator to cool it down before taking the weight of the Petri dish with the sample. Now it has been cooled and we are taking the weight of the food Petri dish along with the food sample. So now it is showing that the weight of the Petri dish along with the sample is 32.5 gram. You have to note it down. And you can also observe that there is a slight decrease in the weight of the Petri dish along with the sample because some moisture has been removed during 2 hours. Now again, we have to keep this Petri dish along with the sample inside the convective hot air oven, and we have to remove it after 30 minutes. And this process of keeping the Petri dish along with the sample inside the oven, removing it, cooling it by putting it in the desiccator, and after cooling it down, we have to take the weight of the Petri dish along with the sample. We have to repeat this step till 3 consecutive constant weight readings, because after that only we can decide that the moisture has been totally removed from the food sample. So I'm repeating the step that I have told you that putting the petri dish along with the sample inside the convective hot air oven, removing it after every 30 minutes, putting it in desiccator to cool it down, and after that I'm going to take the weight. So also I'm recording the weights somewhere. And we can see that the weight is coming constant in 2 steps, that is 31.1 it is coming. So we are waiting for one more constant weight reading, and after that we can stop the process. So here one question is popping up that says weight loss of sample is highest during initial phase of the oven drying method. So what you say, it is true or false? So whatever you think, you can select. Here I have selected answer true. So it is the correct answer. Now this is the observation table where the weights have been recorded, which we have taken after 2 hours initially, and after that at every 30 minutes interval. So here you can see the 3 weight constant readings are there. So now we can calculate our moisture content. So what you can do, you can by taking these values, you can click on this formula, and here you can see the formula, and you can take the weight and enter the value of moisture content calculated manually. Suppose here I am entering 32. So now I can check whether my manual calculation is correct or not. To check that, I will click on check. So this is wrong answer. So I will click on result, and here you can get the correct answer, and the correct values you can put while calculating the moisture content. So in general, how moisture content and food stability are related. So we can say that it is related directly. So this is the correct answer. Now inference, as I told you initially, the aim of this experiment is to determine moisture content in order to predict the food stability. So here in the inference section, you can see a question is popping up that says if a food is having 78% moisture content, so you are going to consider it as perishable food, and it will be having lowest stability. So you can select any of the answer, and you can check whether it is correct or not in the theory written in inference section. So here I have selected false, but the correct answer is true, which you can see here, that the food samples which are having moisture content 15% up to 15% or less than that are most stable, and above 50% they are the least stable food content. So we can easily predict the food stability or shelf life of the food products after calculating moisture content. So this was all about this experiment.